In 3.5, we look at limits at infinity. And what we mean by that is if we have some particular function, what is happening to the function as x approaches positive infinity or as x approaches negative infinity? So in Math 112 and pre-calculus, one thing we saw was that sometimes when we have functions that over time, as we're going farther and farther to the right, we have horizontal asymptotes. So when we find a horizontal asymptote, we are finding that as x goes to infinity, our y value is approaching some particular number. Or as x goes to negative infinity, then y is approaching a particular number. Of course, not all functions have limits as x approaches infinity, or the limits might not be just nice integers. Well, for that matter, even decimals. Sometimes as we go farther and farther to the right, our function keeps on going up forever. So it could be that as x goes to infinity, y could either go up forever or it could go down forever. So in pre-cal, we had kind of a system of various things to test to see whether that was the trick, what happened, whether we had a horizontal asymptote, if we did have a horizontal asymptote, where it occurred. Because at that point, we didn't really have these tricks of limits. We didn't have really any concept of limit definitions. So let's start out by the most basic infinite limit, and that is 1 over x. If we let x get bigger and bigger and bigger, since x is in the denominator, then this quantity is going to get smaller and smaller and smaller. Imagine that we begin with x being 1, and then we let x go to 100, and then we let x go to, let's say, 10,000. Then as, I think I have too many zeros there. Point is, as the denominator gets bigger and bigger, our amount, our quotient, is getting smaller and smaller until it's approaching 0. So as x gets infinitely large, this fraction gets infinitely small, going to 0. And that's going to be true whether we have a 1 on top or any constant on top. This is also going to be true of other powers of x. For example, x squared, x cubed. If the numerator is a constant and we're letting the denominator get infinitely large, as long as this is not a negative exponent, then this is going to be getting closer and closer to 0. So then the question becomes, well, how do we deal with these various limits? So if we were just to directly substitute in, infinity to any power is, or to the 5th power is infinity, plus 8 would be infinitely large. Infinity to the 6th power would be infinity minus 6. So that's indeterminate. So we don't really know who's to say which infinity is larger, how much larger is that infinity. Does this reduce to make 1? Does it reduce to make another number? What is this unknown indeterminate quantity? So what we do is we try to utilize the fact that a constant over x as x goes to infinity goes to 0. So how are we going to do that? So let's pick the largest degree, the largest power of x that we have in our fraction. So in the denominator, we have x to the 6th. So we're going to divide the top and the bottom, each term, by x to the 6th. Or you could say we're going to multiply the top by 1 over x to the 6th and the bottom by 1 over x to the 6th. So when we do that, we haven't taken the limit yet. We're just doing some algebra. So when we distribute the x over 6, we would have x to the 5th over x to the 6th. And when we reduce that, those 5 will cancel 5 of those out, and that'll leave an x on bottom. When we distribute here, that's going to be 8 times 1 over x to the 6th. On bottom, when we distribute, we would have x to the 6th over x to the 6th, which is 1. And then when we do 6 times 1 over x to the 6th, we would get 6 over x to the 6th. So when we take the limit, if we have a fraction, we can take the limit of the top and the bottom separately. If we have individual terms, we can take the limit of each term. So the limit of the first term as x goes to infinity is 0. For the second term, as x goes to infinity, that is 0. The limit of a constant is itself, and this term, as x goes to infinity, goes to 0. So we get 0 over 1, which is 0. Which means for that particular fraction, if our x gets really big, that fraction is going to get closer and closer to 0. Now, what about the middle one? So let's take a look at it. Let's look at the limit of x to the 5th plus 8 over x to the 5th minus 6 as x goes to infinity. So again, by direct substitution, we would get infinity over infinity, which is indeterminate. But since our largest power of x is 5, we're going to multiply top and bottom by x to the 5th. So when we do that, then when we distribute here, we would have x to the 5th over x to the 5th, which would cancel, giving us a 1. And then we would have 8 over x to the 5th. On bottom, when we distribute to here, we would have x to the 5th over x to the 5th, which reduces to make 1, and then 6 over x to the 5th. So when we take the limit, each constant is a constant, but when we have a constant over x, if x is going to infinity, that term is going to 0. So each of these terms go to 0, giving us 1 over 1, which is just 1. So it turns out for this fraction, for this function, as we go closer and closer to positive infinity, our function is getting closer and closer to 1. So we would have a horizontal asymptote of y equals 1. Now if we look at the third one, we have the limit as x goes to infinity of x to the 5th plus 8 over x to the 4th minus 6. Our largest power of x is 5. So we're going to multiply the top by 1 over x to the 5th and the bottom by 1 over x to the 5th. So when we distribute here, x to the 5th and x to the 5th would cancel. When we distribute here, we would get 8 over x to the 5th. On bottom, when we distribute, we would have x to the 4th over x to the 5th, which reduces to make 1 over x. And when we distribute here, we get 6 over x to the 5th. Notice when we let x go to infinity, we're going to get 1 on top plus 0. The limit of a constant is a constant. As x goes to infinity, this term goes to 0. And then on bottom, as x goes to infinity, this goes to 0, and this goes to 0. Which, notice, that's 1 over 0. That's undefined. That's not indeterminate, but that's undefined. Well, what does that mean? If we think about this, as x is getting bigger and bigger, the bottom is getting closer and closer to 0. Well, if we divide by a smaller and smaller and smaller number, then our answer is getting bigger and bigger and bigger. So we're going in the direction of positive infinity. If you think about having x to the 5th on top, x to the 4th, on bottom, if we were to reduce that, which we have some other terms that are kind of insignificant in terms of infinity. So, but if we only look at the x terms, that would reduce to x. If we let x go to infinity, then that's going to go towards infinity. So we're not going to a particular number. We're getting bigger and bigger and bigger. It's growing infinitely large. All right. So then we have some that have square roots. So one question here is, how do we determine what to divide the top and bottom by? On top, the largest power of x is x to the first. On bottom, the largest power of x is squared, but that's under a square root, which is basically x to the first. So we need to divide top and bottom by 1 over x to the first, because x to the first is essentially our largest power of x. But the problem is that when we multiply this on bottom, if that denominator is not under a radical, how do we multiply that fraction times that radical? Well, we can't combine them unless that fraction is under a radical. We can do that. We can put it under a radical, under a square root, as long as we also square it. So that has the limit as x goes to, I'm going to come back to infinity in just a second. X on top times 1 over x. On bottom, we have the square root of x squared minus x and the square root of 1 over x squared. Notice the square root of 1 over x squared, if we were to take the square root of that, that would just be 1 over x, which is what we have on top. Now here's where we have to be careful, and I wish I would have done these in a different order, but if we were going to positive infinity, let's compare or look at the fraction 1 over x over 1 over x squared under the radical. If x is going to positive infinity, these two things are the same. Because, as we said, the square root of 1 over x squared is essentially 1 over x, and these would give us the same value. Anything divided by itself makes 1, so we could do this and we would be okay because that is essentially 1. But that's not going to be true if we're going to negative infinity. Now, you might say, why? Well, let's real quickly look at, well, are we sure that as we're going towards positive infinity that this really equals 1? So let's just pick a couple of numbers. If we put a 10 in for x, we get a 1/10 on top. Under the radical, we would get 1 over 100. But when we take the square root of that, the square root of 1 is 1, the square root of 100 is 10. Those are the same amount, so those make 1. If we put in 1,000, we'd have 1 over 1,000 on top, 1,000 squared, that would have 6 zeros, so that would be, I guess, 1,000,000. Let's double check. 1,000 squared is 1,000,000. So if we have 1,000,000 under the radical, and we're doing 1,000, not 100. So we'd have 1 over 1,000 on top. If we take the square root of 1,000,000, we would get 1,000. That reduces and makes 1. So as x goes to positive infinity, this fraction is equivalent to 1. So we could use this fraction to find this limit. So let me erase this so we have room. So if we distribute, on top, the x and the x would cancel, leaving us 1. Since this is under a radical and this is under a radical, then we can distribute. We can do x squared times that. Well, x squared on top, x squared on bottom would cancel, leaving us 1. And when we distribute here, x over x squared would reduce to 1 over x. And if we take the limit of that, as x goes to infinity, then the limit of a constant is itself. The limit of 1 over x as x goes to infinity is 0, and we would get 1. But what if x is going to negative infinity? What if x goes to negative infinity? Then is it true that 1 over x over the square root of 1 over x squared, is it true that that equals 1? And the short answer to that is no. Well, how could that be so? Let's look by picking some negative numbers that are getting bigger and bigger. If we put in a negative 10 for x, we get positive over a negative, so negative 1/10 on top. On bottom, negative 10 squared is 100. When we take the square root of that, the square root of 1 is 1, the square root of 100 is 10. The notation square root implies a positive value. But if we're letting x go to negative infinity, the numerator is negative. Well, if the bottom is positive and the top is negative, that's negative. Anything divided by itself makes 1. So this fraction is actually equivalent to negative 1, not positive 1. If we pick, let's say, negative 100 to replace x, we're going to see the same thing. As x is getting bigger and bigger in the negative direction, we're not going to positive 1 here. So negative 100 squared is positive 10,000. So we get negative 100 on top. The square root of 1 over 10,000 is 1 over 100. That reduces to make negative 1. If I multiply something by negative 1, that changes how much I have. So how do we handle this? Well, if we're letting x go to negative infinity, and we've determined that this amount actually makes, let me not put equal there, that this amount is equivalent to negative 1, then to make it positive 1, we could multiply it by a negative. The opposite of a negative is a positive, so I could just put a negative in front of that fraction, and it would change that negative 1 into a positive 1. So we're going to take the limit as x goes to negative infinity, and when we have x over the square root of, what was it, x squared minus x. Our largest degree is x, so we're going to put a 1 over x to the first on top. On bottom, since it's under the radical, 1 over x squared. And since we said that as x goes to negative infinity, that this fraction would be negative 1, then to make it positive, put a negative, so that now it's equivalent to a positive 1. If you were to replace x with the negative numbers, then you would have a positive over a negative times a negative, which would make it back to positive, and the bottom is always positive. So if we distribute here, we only have to worry about this when we have a square root that we're multiplying by. So on top, we have a positive times a negative, x on top, x on bottom, that makes 1. When we distribute on bottom, x squared on top, x squared on bottom cancel, leaving us 1. And when we distribute and have x times 1 over x squared, that leaves us with 1 over x. So when we take that limit, we get negative 1, the square root of 1 minus 0, so negative 1 over the square root of 1, or negative 1. So if x is going to positive infinity, then we were going to positive 1, but if x is going to negative infinity, we would go to negative 1. And again, we only have to worry about this when we have a square root involved. Because if one of the fractions is under a square root, but one fraction is not under the square root, to make it 1, if it's going to negative infinity, we have to be careful with our sign. So let's take a look at another one. On top, we're under a radical, so essentially that's an x to the first, because the square root and square would reduce each other. On bottom, we have an x to the first, so our largest power of x is 1. So we're going to multiply the bottom by 1 over x to the first. Since it's underneath the radical on top, instead of being just 1 over x to the first, we need to put that under the square root and square that fraction. Since we are going to positive infinity, then it is true that this fraction equals 1. As x goes to positive infinity, this fraction equals 1. And remember, when we're rewriting something, we don't want to change how much we have, just what it looks like. So we want to multiply by 1. So on top, when we distribute, x squared times 1 over x squared, the x squareds cancel, making 1. When we multiply the 7 times 1 over x squared, that's 7 over x squared. On bottom, when we distribute 5x times 1 over x, the x's cancel. And when we multiply by 3, we get 3 over x. So once we get to this part, now that each term has a constant on top and x on bottom, the limit of any constant is itself. If we're letting x go to infinity, then this term is 0. The limit of a constant is a constant, and this term goes to 0. So that makes 1/5. So if I didn't say it clearly at the beginning, the reason that we're multiplying or dividing on each term, when we take the limit, we want each term to either be a constant or a constant over x. A constant or a constant over x, because the limit of a constant is itself. If we have an x on bottom, a constant on top, as x goes to infinity, that term goes to 0. If we have an x on top, then as that goes to infinity, then that term goes to infinity. But if we have a constant and then a constant over x, each of these terms go to 0, each constant remains a constant.